Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about properties of ionic compounds. I'm going to break up this PowerPoint into two videos. And this first video is going to cover melting and boiling points, electrical conductivity, and hardness and brittleness. So just a reminder what ionic compounds are. Ionic compounds, the particles are ions. The bonding is ionic. And the ionic bonding means that the particles are held together with strong electrostatic forces of attraction between positively and negatively charged ions. And in the solid, the ions are held together in a 3D lattice with a regular arrangement. That means a lattice means a regular arrangement. So there's the positive ions, like the sodium and the chloride ions in sodium chloride. And there's a 3D picture of what the ions look like in a crystal. So these things that we talked about, the 3D lattice, the fixed ions in the solid, they don't move and they have really strong ionic bonds. So therefore, ionic solids have high melting points. They are hard but brittle. That means they will smash when hit with a hammer. They dissolve in water to create solutions, and they do not conduct electricity when solid, but they do conduct electricity when they're in a solution or when they're molten, which means they've melted. However, if they melt, they need lots of energy to break the bonds between the ions. So they have really high melting points. Okay, so we say they need considerable energy to break the strong ionic bonds in the lattice. For example, magnesium oxide has a melting point of 2,852 degrees centigrade, and it's used in furnaces like this big industrial furnace around the outside because it's not going to melt. Okay, so what kind of exam questions can you expect on melting point, boiling point? So for example, explain why sodium chloride, NaCl, has a melting point of 801 degrees centigrade. So in your answer, you need to use your knowledge of bonding and structure. Excuse me, I'm going to cough. Use your knowledge of bonding and structure. You need to say that it's ionic substance, it has positive ions, negative ions, held together with strong electrostatic forces in a 3D lattice. So this bit here is just stating what you know about ionic solids. And then you need to say that the bonding is very strong. And so therefore, a large amount of energy is required to overcome these forces, the bonds holding the ions together, and results in a very high melting point. Another feature of ionic solids is that they can conduct electricity under certain conditions. So to conduct electricity, a substance must have free-moving charged particles. Now, those charged particles can either be electrons or ions, okay? They're both charged particles that can carry a current. So in an ionic solid, we have ions, but when it's in the solid, that crystal, the ions are fixed. They can't move, and therefore they do not conduct electricity. So ionic solids, when they're solids, cannot conduct electricity. However, if we melt the solid, and we know that we need a very high energy, very high temperature, but if we can melt them, then the ions can move, and therefore, in that situation, they are going to conduct electricity. Another example when the ions can move, if you have a solution like in this picture over here, you've got positive and negative ions surrounded by the water solvent, and so the ions can move, and therefore you can create a current in that solution, and so dissolved ionic compounds are also good conductors. So here's an example of an exam question that you might get. So zinc chloride will not conduct electricity when solid, but will conduct when molten. So justify this statement in terms of the particles, the structure, and bonding for the substance. So justify means you have to give the reasons. So electricals, this part here, you're just stating what you need for electrical conductivity. You need the presence of charged particles that are free to move. Now remember, that can be electrons or it could be ions. So zinc chloride is an ionic compound that cannot conduct electricity when solid because, all right, important use of the word because to give the reason, the ions are fixed in place in a 3D lattice structure and are unable to move. When molten, the ionic bonds between the ions break, so the ions are free to move in the molten liquid. Therefore, with ions free to move, zinc chloride can then conduct electricity. Ionic solids are hard and brittle. So they're hard, so then hard crystals, but they're brittle means that if you hit them with an external force like a hammer, then you disturb the lattice, and then the like particles, like ions with the same charge are going to line up, and that's going to be where the crystal cracks, because these like ions are going to repel each other. So an example exam question about that is explain why zinc chloride is not malleable. Malleable means if you hit it, it's going to bend. But if you hit a crystal, it's going to shatter, and so that's why it's brittle. So you just again say that this first part of when you answer exam question, you state what you know about ionic solids. It's a regular array of zinc and chloride ions held together by ionic bonds in a 3D lattice. Then you say it's not malleable because, again, that use of the word because, if pressure is applied to an ionic lattice, it forces ions with the same charge next to each other. They repel each other and break the structure. Zinc chloride is therefore brittle. So in this first video about ionic solids and the properties of ionic solids, we've talked about how they can conduct electricity under certain conditions. They have high melting points and they're hard and brittle. In the next part of the video, we're going to talk about why ionic compounds dissolve.